Hi, this is Sarita. Today I'm going to discuss about the topic CoAP protocol. CoAP means Constrained Application Protocol. Means this protocol is for applications where some constraints we need to follow, like memory constraint, memory is limited, power is limited, or bandwidth is limited. So in short, we can say this application protocol, constrained application protocol, is for the IoT applications and M2M, machine to machine applications. CoAP is a IoT protocol which is based on one-to-one protocol, and it follows client server paradigm. Means it will be like requesting, and the response to the request will be sent. That is the way HTTP also following. So CoAP is also similar to that way, and CoAP is defined in RFC 7252 and is a simple protocol with low overhead, specifically designed for constrained devices. Constrained devices means, with, as I told, it is with minimum power, low bandwidth, low memory, low processing power. So we can use this CoAP with IoT devices applications. I told you already what is meant by the constrained devices. Constrained devices majorly means the processing power is lower, the size of the buffer is lower, minimum, and the power supply availability is minimum, and bit rate is minimum. Cost wise, lower cost we prefer, and the physical size will be the minimum. MQTT and CoAP underlying protocols for IoT. Here in this diagram, we can see the MQTT protocol and CoAP protocol. We can see the comparison of MQTT and CoAP. MQTT is totally based on TCP, while CoAP is laid on UDP protocols. So whatever UDP features are there, CoAP follows that, and it is supporting IPv6. And now you can say the normal HTTP cloud, the internet, it is depending upon TCP or UDP. But whenever, if the base layer is on TCP, we can go for MQTT protocol. If it is supporting UDP, we can go for CoAP protocol. The MQTT protocol, it will be, all the devices will be connecting to MQTT broker and then the other clients. But in the case of CoAP, the CoAP one-to-one message service is possible. Means one-to-one connectivity is possible, request and the response. Now the CoAP layers, you can see CoAP layer, two layers are there majorly, the message layer and request response layer. The message layer deals with UDP. Message layer is connecting to UDP layer with asynchronous messages, and the request response layer, it will manage the request response interaction between the applications based on request response messages. So normal TCP IP stack and IoT stack, the comparison you can say. Here in TCP IP stack, the application layer majorly on protocols like HTTP, FTP, SMTP, etc. And you can say here MQTT also will be coming in. But in IoT stack, here in application layer, it will be supporting CoAP. If it is for constrained applications, it will be depending upon, it will be supported by MQTT also. Means if the application is constrained, then instead of normal HTTP, we will go for MQTT for TCP/IP. But if it is UDP based system, then we will go for CoAP protocols. HTTP, it works on REST protocol. Means REST protocol means it is just the any web service, it is working on REST. Means all the page by page, the whenever it is represented, you need the support of REST protocol. But whenever it is coming for CoAP, we need the constrained REST protocol. So CoAP gets the support of constrained REST protocol. CoAP support for different message types: confirmable, non-confirmable, acknowledgement, and reset. So here, confirmable messages. In CoAP, a reliable message is obtained using confirmable message. The message sent will be reached at the receiver. So we will make sure that the whatever message we send safely reached at the receiver side. So that confirmation or acknowledgement will be received in the case of confirmable messages. So the main feature is acknowledge message containing the same ID. So the ID here means every request sent by the message sent by the sender will be having an ID. Every request will be having an ID. The acknowledgement will be having the same ID, representing that this is the acknowledgement according to your request. So these two should be the same. And confirmable messages, you can see the client and sending request to server, you need to say the type of the message, whether it is confirmable or non-confirmable. If it is confirmable, CON, and the message ID will be there. And when it is server is sending the acknowledgement, it has to say the ID, the number, the representation a server has to send with the acknowledgement. If the server has say there is some problem in the connectivity between the client and the server or some other issue, so instead of sending the acknowledgement with the data means the client was trying to get the temperature from the server, and that time if there is no issue in the connectivity or in that request receiving message, then it will be sending, the server will be sending an acknowledgement with same ID, message ID, and with the data. So the data here is 20.1 centigrade. So that data the client will get. Suppose some issue is there in the incoming request, then it is requesting temperature with ID this 46, and the server will be sending the acknowledgement, and it will be sending a message saying that not found. Means that can be a printf statement saying the error. So that is the way, but it will get an acknowledgement. So non-conformable messages. These are messages that don't require acknowledged by the server. Obviously, it will be unreliable messages, or you can say the message, whenever it doesn't contain any critical information, we can just rely on non-conformable messages. To this category, messages that contain values read from sensors. Example, you can say If the sensor is continuously sensing temperature, one or two readings in a second or in a couple of seconds, if it is missing also, there is no problem in the communication in the entire system. So it can work with the previous available data, immediate previously available data. So one or two data, if it is missing, it doesn't matter. So we can rely on non-conformable messages in that case. Even if these messages are unreliable, they have a unique ID here also. So here the client is sending say temperature data to the server, and there will be an ID to this. It will represent it as no. And CoAP request response model. So we are moving to the second layer of the CoAP. Uh, second layer of the CoAP is the request response layer. So this request response, the request is sent using, obviously it may be sending us conformable or non-conformable message. The constrained application CoAP message format. The constrained application protocol, which is meant for constrained environments, so it uses compact messages. The message length should be minimum as possible. To avoid the fragmentation, message occupies the data section of a UDP datagram. CoAP message is made by several parts, just like the MQTT protocol. So here, the layer, the first layer, first byte of the message, so many fragments you can say, you can see division of the entire length of the message. This is TKL code and message ID. So let's see what all these things are. Next byte will be about the token number and optional and some payloads. So payload means the actual data you will attach to that. And variable VAR means it's a 2-bit assigned integer indicating the version. So what version of message you are sending, you will say here. And the T indicate the type. Type means, as I told you, the message can be conformable or non-conformable. So the type of the message can be conformable, CON, or NON. So if it is conformable, you will say it as 0, and if it is non-conformable, you will say it as 1. So it will occupy 2 bits of unsigned integer indicating the type. And the third one is TKL, that is your token length. Token length occupies 4-bit length. And the next is the code and message ID. And code is the code response, message ID, and it is expressed in 16-bit. So this entire bytes will be occupying the details of the message. And the CoAP security aspects. Whenever we are using some protocol, the major concern will be the security. CoAP is based on UDP. So whatever security UDP is having, all these are possible with available with CoAP also. You know the HTTP that uses transport layer security, TLS, over TCP. But here also CoAP, it will use the UDP. So it will be using datagram TLS over UDP. So it may be supported by algorithms like RSA, AES, and so on. Let's see what all are the differences or similarities between CoAP and MQTT. Both are used in IoT. MQTT uses publisher subscriber paradigm, while the CoAP uses request response paradigm. MQTT uses central broker to dispatch the messages. Means client will send data to the broker will distribute that data to other clients, whichever is requesting for that data. MQTT, so you can say MQTT is a many-to-many communication protocol passing messages between multiple clients through the MQTT broker. So there is a central controlling element is there. That single point of contact is there. That's a disadvantage also. But in case of CoAP, it is essentially a one-to-one protocol. Means every device can communicate to each other. Two devices, it can communicate to each other without a middle device. It's very, so it is, you can say, very similar to HTTP protocol, but it works on UDP. MQTT is an event-oriented protocol, while CoAP is more suitable for state transfer. So CoAP is supported by REST protocol. So it is mainly based on state transfer. Means entire web page, how it is represented at the client side, all these things will be supported by the REST protocol. So that is a major advantage of CoAP over MQTT. And that's all about the CoAP protocol. As we were discussing, it is majorly for the IoT devices, and MQTT constrained devices. We can use MQTT or CoAP, but if you compare between the two, CoAP is more lighter than MQTT. So whenever constraints are more, uh, then you can go for CoAP also. That's all. Thank you for watching. Thank you.